Hello friends, Dr. Rick Bennett here. On behalf of Waiwai Ohana and Applied Life Sciences, we are offering this two-part video as a public service to help landowners distinguish whether they have a cesspool or a septic system, to help landowners decide that as they build a new home or they do a significant addition to an existing home, or what septic systems might be required and what they can expect in today's world from the county building department and the state Department of Health. So we'll look at what types are out there, and we're going to examine the question, is there any real difference? And talk about the problems that we face. So we live on an island, and almost all of our fresh water comes to the island via rainfall. It percolates down through the fractured lava to sea level, where the fresh water displaces seawater because it's lighter, and that distance on this graph, called H, is the freshwater lens that we drill into and pump fresh water for domestic purposes. All the while, seawater intrudes into the freshwater lens as much as a mile or more inland, but the net flow of that water with the seawater mix is going out, especially with an outgoing tide. And so this mixing process rises and falls 4 times a day. And that is where our fresh water goes, and that's how it cycles back into the ocean. Graphically, we can see this with infrared photography. This is done by UH scientists. And the very blue water back there in the back part of Honokahau Harbor is some pretty cool water. It may be in the high 60s, low 70s, and shows up infrared as blue. As it moves out towards sea through the harbor or through the groundwater discharge sites, as pointed by the lines on this image, it mixes with the seawater and gets a little warmer and a little warmer. And by the time it's well offshore, it's the same temperature as the seawater. This brackish freshwater floats on the seawater. The brackish water also contains a fair amount of the nutrients, nitrogen and phosphorus. You might know those as fertilizers. And in the ocean, they act like fertilizers. And that is a problem for the tropical waters of any island. Tropical waters are typically nutrient poor, and it's why they are so clear and pristine. And so nutrients from human activities on the land percolate down to the groundwater and flow out to the sea in what we call a subterranean estuary. Well, these flows of nutrient-rich groundwater have caused almost every nearshore location on the Kona side and many on the Hilo side to be recognized as impaired by the state and the federal government under the Clean Water Act. And so because they are listed as impaired, we are obliged to remediate that impairment. But the cost of remediation is so extremely high that the state has not required that mitigation. And so now for almost 20 years, more and more sites become impaired, and that happens really as a function of human activities. Now you'll notice down between Honaunau and Milili'i, there are no impaired waters listed. 2 reasons. 1, it's hard to get to sample, but I think the most important reason is There's very, very low population density down there. And so the flow of nutrients from human activities is minimal compared to North and South Kona. So this problem is not new. Wherever there are human communities next to bays and estuaries and inlets, like the Long Island Sound, like the Chesapeake Bay, nutrients flow, and that can be modeled on a household basis. And so I took the 2010 census data for North and South Kona, and giving the data from the RIE study, cited above, that between 200,000 and 377,000 pounds of nitrogen flow into the groundwater and into the sea each and every year. And that is why it is so easy to detect nitrogen in the groundwater in Kailua Kona. So what do these nutrients do? They grow undesirable plants in the sea. In the upper left corner, we see algae growing and covering coral. This is very detrimental to the coral. In the situation in the lower right-hand corner, we have a healthy coral reef, and after many years of wastewater discharges well inland, the reef simply dies. And in Keauhou Bay, which was where this canoe paddle picture was taken, the bay has very, very poor circulation, and the nutrients spike a phytoplankton bloom almost every year, and the turbidity increases and the visibility decreases to the extent you can't even read the name on the paddle. So what can we expect from various types of septic systems? So let's look at the conventional septic system, which is a septic tank and a leach field. We can expect about 20% reduction or removal of nitrogen. And this is in particularly possible when there is high quality soil present, such that the soil has filtering ability. It also creates an environment where the bacteria can literally convert the nitrogen from nitrate to nitrogen gas, and the gas goes off into the atmosphere in a harmless transfer. Cesspools, which is literally a hole in the ground, lined or unlined, can have similar removals as long as there is soil in the cesspool. So there's standing water that goes really anaerobic, gray, foul smelling, and nitrogen can be reduced there. The most encouraging septic system is a sand filter system, in some cases a recirculating sand filter system, that we lovingly call the layer cake, or the nitrogen reducing biosystem, NRB. This was tested and documented at Stony Brook University in order to address the pollution problems in the Long Island estuary. So here we can get a 90% reduction in nitrogen. This same technology now is available to homeowners in Kona, where we can incorporate the sand and sawdust system to get a 90% reduction in nitrogen in the effluent. So what's a cesspool? It's a hole in the ground that may or may not be lined. It may or may not be a concrete tank with a drain. In some cases, it's just some concrete with holes in it that allows the liquid to drain out to the groundwater. And so cesspools and cesspits leak by design. The green water is not pollution. It is a dye that was put into a cesspool in Puako. And in the matter of hours later, the green dye emerged in the nearshore waters, establishing the fact that cesspools are designed to leak. So many states now are removing traditional septic systems because they do not effectively reduce nitrogen. States like Maine, New York, Massachusetts, and Florida are requiring nitrogen-removing septic systems. In coastal Florida and in the Keys, traditional septic leach fields are draining bacteria, pathogens, and nutrients into the waterways and causing pollution, causing turbidity in virtually every waterway in Florida. The Chesapeake Bay has been overnourished for decades. Bacteria flourish and the process of eutrophication occurs, where the bacteria utilize the oxygen dissolved in water, and you get deaths of fish, you get death of seagrass, and parts of the Chesapeake Bay have become literal underwater deserts, devoid of life. In California, in Stinson Beach, it's been shown that septic nitrogen and septic bacteria move through the groundwater and the sand and emerge in the sea, especially at low tide. So this is a universal problem that really needs our attention. So this may be a good place to take a break and come back and resume here at part 2. And here we're going to talk about solutions. There are simple, cost-effective, biological solutions as opposed to engineering solutions. And they are ready for implementation in Hawaii. And what we're doing is we're cultivating microbes, special kind of microbe, that can convert these nutrients into other forms and keep them out of the groundwater and keep them out of the nearshore waters. So a very careful review of the world's science in this regard showed us the problem. The problem is conventional septic systems, as recommended by the state and counties, will fail to attain our policy goals of protecting groundwater and the nearshore waters of Hawaii. It'll fail to keep the pathogens out. They will fail to keep the nutrients, nitrate and phosphate, out of the groundwater. What is the solution? A nitrogen-reducing biosystem, or if one chooses to spend the money, there are select brands of advanced treatment units, known as ATUs, that have documented performance that will attain state and federal water quality objectives. For example, the state of New York certifies certain ATUs as acceptable and denies certification to others. And so as of about March 21, 2016, cesspools are no longer permitted in the state of Hawaii. This is in Administrative Rule 11-62, Section 36. Basically says no new cesspools shall be constructed without the approval of the director. And by and large, the director will not approve them unless there are very extenuating circumstances. New waste systems, like the photograph in the upper right-hand corner, require a permit that the wastewater engineer for the customer must hire to apply for that permit, and that permit must be granted by the Department of Health before the County of Hawaii will provide a building permit. Any nutrient reduction for these new and approved septic systems is not required. The state has basically paid no attention to the nutrient contamination that is associated with these new and approved systems. So in effect, the septic system removes solids, removes some of the nutrients that cause bacteria to grow and strip oxygen, but they really do nothing to remove the nitrogen and phosphorus. And so functionally, they are no better than a cesspool. So here's a picture on the upper left of a modern cesspit that was constructed in 2016. It was approved in 2015, and so being grandfathered, it could be installed. And this is a series of rings with some slots in them that allows the liquid to diffuse out. Now, the photograph in the upper right shows a septic tank draining into a cinder block lined pit. And this is and can be an approved septic system simply because it has a septic tank. But let's be clear, septic tanks by and large do not remove nutrients from the wastewater. The state says this is an improvement and it protects groundwater and marine waters. I beg to differ. They talk a lot. But as this famous man said, stop talking and show me the data. I have yet to see the data. So approved septic systems in Hawaii look like this. The upper right is something we may see in South Kona where we have no soil. We've got lava rock and blue rock. It must be excavated with a hammer and then backfilled with cinder and gravel, then further backfilled. And so it's simply a disposal line as opposed to a septic treatment area. Now in the photo on the left, this could be Kalakakua, it could be Kauai, where we've got red dirt soil. And in that situation, there is much, much better filtering by the soil and perhaps a little bit of anaerobic nitrogen removal, but by and large, not. Same for the photograph in the center and similar for the photograph on the left. The photograph on the left and on the right represent modern septic systems that can cost upwards of $15,000 to $20,000 to install. But we can do better. Septic systems that remove nitrogen and phosphorus are being applied in many states, and in many states like New York and Florida, they're actually being required. And so there are many forms of nutrient-reducing biosystems for the home or for the neighborhood. So here's a diagram of a nutrient-reducing biosystem. It's simply a trench that's lined with a liner and a drain, then 18 inches of sand and lignocellulose, sawdust if you will. Composted mulch from our landfill can be used. On top of that is 18 inches of coarse sand. On top of that is the distribution system, as seen on the photograph on the left here, that provides a more uniform disposal of the septic tank leachate. And both of these layers create two unique microbiological systems. One that uses air, one that does not. And as a result of these little microbiologists, these little chemists, it can remove 90% of the nutrients and reduce the potential pathogens to near zero, which is a major, major improvement over a conventional leach field. At the community scale, these systems can be built to handle multiple homes. And one of the most encouraging developments is something called a membrane bioreactor. It is a mini wastewater treatment plant that can be put in a 20 to 40 foot container like we see on the backs of trucks, the ones that are stacked 10 high on ocean-going transports. So these MBRs, as they're called, could be installed in neighborhoods as pictured below. That happens to be miloli'i. And so clusters of homes could be serviced by a membrane bioreactor. Here, these systems are going to be too expensive for homeowners to finance, but there is increasingly various types of federal grants and federal programs that will purchase these things and install them, and then the community can be responsible for hiring a manager to manage the system such that they don't have to. So we have the ability to keep the wastewater and its nutrients out of the ocean. And the best thing we can do is irrigate it, because the irrigated plants will capture the nutrients, they'll capture the water, and keep it out of the drainage to the sea. So as I say, green lands are far better than green oceans. We can do this. We must do it. If not for ourselves, for our children. Mahalo for listening.